Hello friends, welcome to Learner's Planet. Friends, this is our second session for trigonometry. In the previous session, we discussed all the basic concepts related to trigonometry. We discussed the 6 trigonometric ratio, that is sine theta, cos theta, tan theta, cosec theta, sec theta and cot theta. We derived the relationship among each other. So in this session, we'll be start taking problems based on trigonometry, right? So let's begin the session. Now friends, the first pattern of question that's very common is we are given just one value of one trigonometric ratio and we need to find the value of all other 5 trigonometric ratios. Any one of them may be given, right? In this case, we are given the value of cos theta, that's 2 cos theta is 2 by 5 and we have to find sin theta. In fact, in this question, we'll be finding all other 5 trigonometric ratio, that is sin theta, tan theta, sec theta, cosec theta, cot theta, right? So just listen to me carefully. I'll be discussing 2 methods with you how to find out all other trigonometric ratios. Now 2 cos theta is 2 by 5. That means what? Cos theta is equal to 1 by 5, right? Now we know the relationship between sin theta and cos theta, that is, we have already derived the formula. Sin square theta plus cos square theta is equal to 1, right? So value of sin square theta plus cos square theta is always 1. Now we just put the value of cos theta as 1 by 5. So square of 1 by 5 will be 1 by 25 and that's 1. So sin square theta is equal to 1 minus 1 by 25, that's 24 by 25. So sin theta is equal to plus minus 24 by 25, right? Or you can simplify that, that's 6 into 4, so 2 we can take out as common and by 5, so it's this, right? So it's plus minus 2 root 6 by 5, the value of sin theta. So we got the value of sin theta, value of cos theta is already with us. Similarly, we can find out the value of other trigonometric ratios. What will be sec theta? That is 1 upon cos theta. So it's 1 by 5, so sec theta will be 5. What will be cosec theta? It will be reciprocal of sin theta, so it's 5 by 2 root 6. As of now, we are just taking the positive value because in grade 10, you have to deal with the positive value of this all the 6 trigonometric ratios, right? So this is what sec theta, this is what cosec theta. Now we have to find out tan theta. Now tan theta is actually what? Sin theta by cos theta, right? So what is the value of sin theta? That is 2 root 6 by 5. What is the value of cos theta? That's 1 by 5. So tan theta will be equal to 2 root 6, right? So this is how we can calculate. And tan theta is 2 root 6, that means cot theta will be 1 upon 2 root 6, right? So we calculated all the other 5 trigonometric ratio if we know 1. Okay. Similarly, we can find out all other trigonometric ratios by the use of this right angle triangle also. Let's see how to do that. Now cos theta is 1 by 5, that's given to us. This angle must be theta, right? Now cos theta is what? That we already know, that is base by hypotenuse. Now 1 and 5, nothing is common between them, so we can take the value of or we can say base is to hypotenuse is in the ratio of 1:5, right? So we can take the base as k and hypotenuse as 5k, so they can maintain the ratio of 1:5, right? Now we know these two, so we can calculate this also by the use of Pythagoras theorem. So suppose this is OPQ, so that's OQ square plus OP square is PQ square, right? So what OQ square? That's K square plus OP square is we have to find out is equal to PQ square is 25K square, right? So OP square is 25K square minus K square is 24K square. So OP will be root 24K, right? So it's root 24K. Now we got all the three sides of this triangle, so we can calculate all the other ratios. What sine theta will be? It's perpendicular by hypotenuse, so root 24 by 5. That we have already calculated. Cos theta we have already there. Cosec theta will be reciprocal of sine theta. Sec theta will be reciprocal of cos theta. Then tan theta, we have two relations for tan theta, that is sin theta by cos theta, or we can say perpendicular by base. So root 24K by K, so that's root 24, and cot theta will be equal to 1 upon root 24, right? So there are two ways to calculate the say 5 trigonometric ratio if one is given, right? And it's really simple. You should be clear with both the methods, so whenever you wish you can apply the same, right? Now in this question we are given sin x, so we assume this angle to be x, and this is perpendicular, this is base, this is hypotenuse, right? Now sin x is 12 by 13, so it's 12 is to 13, so we take as 12K and 13K. So perpendicular is 12K and hypotenuse is 13K, right? Now by using Pythagoras theorem, p square plus b square is equal to h square. So we put the value of p and b and get the value of put the value of p square and h square, and we'll be getting the value of b square. So how do we do that? P square, that's 144 k square plus b square, h square is 169 k square. So b square is 169 minus 144, that is 25k square. So b will be 5k, right? So we got the value of base, that's 5k, right? Now we have to find out the value of 10x. So what will be 10x now? It's perpendicular by base, so 12k by 5k, so it will be 12 by 5, right? What will be sec x? It's opposite of cos x. So cos x is what? 5k by 13k, that's base by hypotenuse. So sec x will be hypotenuse by base, so it will be 13 by 5, right? And cos x square, this is cosec square x minus cot square x. We have to calculate that. Now what is cosec square x? Cosec x will be reciprocal of sin x. So cosec square x will be what? 13 by 12 square. So that's 169 by 144 minus cot square x. Cot x will be reciprocal of tan x. So it's 5 by 12. So the square will be 25 by 144. So it's 144 by 144, that's 1. So friends, the value of cosec square x minus cot square x is always 1. This is the derivation that we did in our first session, that 1 plus cot square x is equal to cosec square x, right? So we were having the value of sin x and we calculated all the other values this way, right? You can use the trigonometric identities also like this. So anyways you can do it. Now similarly we take this question. If 5 cos theta is equal to 3, we have to evaluate this given expression. Now further there are two ways. Either you just calculate the value of sin theta as well by putting the value of cos theta, or directly what you can do is you divide the entire expression in the numerator and the denominator by cos theta, right? So we can go either way. See, cos theta is actually 3 by 5, right? Now we know the relationship that sin square theta plus cos square theta is equal to 1. Just put the value of cos theta. So it's sin square theta plus 9 by 25 is equal to 1. So 9 sin square theta is equal to 1 minus 9 by 25, or we can say 16 by 25. So sine theta will be equal to 4 by 5, right? Now we know cos theta, we know sine theta. Just put the value over here in this given expression. That's 3 into sine theta is what? 4 by 5, plus 2 into cos theta is what? 3 by 5, by 3 into 4 by 5 minus 2 into cos theta is 3 by 5, right? Now it's 12 plus 6, so that's 18 by 5, but the denominator will get cancelled from this 5, and this is what? 12 minus 6, right? So that's 6. So the value of this expression is 3, right? It's very simple, friends. You just have to put up the value of trigonometric ratios in the given expression. That's it. Just simply solve it. Like if you know arithmetic very well, do not make the calculation mistake. That is a biggest thing, right? Now friends, let's take trigonometric identities that we have to prove. A good number of students are always scared of or afraid of all these trigonometric identities. They really find it very difficult, but believe me, it's really very easy, right? You just have to follow certain rules and a good amount of practice. So just listen to me carefully, step by step, see the solution, so you gain the confidence in solving trigonometric identities, right? The basic formula that we will be using over here will be the three relationships, that's sine square theta plus cos square theta is equal to 1, 1 plus tan square theta is equal to sec square theta, 1 plus cot square theta is equal to cosec square theta. So these are the three relations, and apart from that, algebraic identities we have already discussed. So these identities and algebraic identities will be using to establish the given identities, right? Tan theta is equal to sine theta by cos theta. This is also useful, and other like sine theta and cosec theta are reciprocal of each other. So sine theta into cosec theta is 1, cos theta into sec theta is 1, and tan theta into cot theta is 1, right? So these identities will be used. Now let's take this first question. It's sec a minus 1 by sec a plus 1 that we have to prove. 1 minus cos a, 1 plus cos a. Now just see it carefully. On the left hand side you are given the relation in sec theta. On the right hand side you have to convert the relation into cos theta. That means sec theta is nowhere in the right hand side, and apart from cos a, no other trigonometric ratio is there. So simply what you can do, you just convert sec theta into cos theta. Here it is a, the angle is a, so use a. Doesn't matter whether it is sec theta or sec a, right? So simply you just convert sec a to cos a. Now how do we do that? Sec a is what? 1 by cos a. So instead of sec a, what I do, I can put 1 by cos a. Now whenever you have to establish the trigonometric identity, you have to start with one side and you have to reach the other side. So be very careful. You should not generally solve both the sides, right? So we start with left hand side, that's LHS. Now what LHS is? It's sec A minus 1, sec A plus 1. Now to gain the complete mark for a particular problem, just follow all the steps, right? Just try to write everything, right? Sec a minus 1, sec a plus 1. Now we know that sec a into cos a is equal to 1, right? Suppose this is the first equation. Now sec a into cos a is 1. That means sec a is equal to 1 upon cos a. Now putting the value of sec a into 1. Okay, so sec a is what? 1 by cos a. I put it over here. It's 1 by cos a minus 1 upon 1 upon cos a plus 1. Simply take LCM of numerator and denominator. So it's 1 minus cos a by cos a by 1 plus cos a by cos a. So this will be cancelled. So we are left with 1 minus cos A by 1 plus cos A, that's right hand side, right? So we started with left hand side, that's sec A minus 1 by sec A plus 1, and we keep on solving and we reach right hand side, that's 1 minus cos A upon 1 plus cos A. So this is how the trigonometric identities are proved. You start with one side and you reach the other side, right? Okay, I hope you are clear. Now we have this question. Sin theta into tan theta by 1 minus cos theta is equal to 1 plus sec theta. Now we have to prove this identity. Further, we'll start with the left hand side. That's sin theta tan theta upon 1 minus cos theta. That's left hand side. Now what is tan theta? In the right hand side we just want sec theta. So what we can do is we try to convert all the relationships into a common trigonometric, a single trigonometric ratio, right? So tan theta can be written as sin theta by cos theta. So it's sin theta into sin theta by cos theta 1 minus cos theta, right? So it's, write it over here, sin square theta upon cos theta 1 minus cos theta, right? Now sin square theta can be written as 1 minus cos square theta, and then we have cos theta 1 minus cos theta. Now that's what a square minus b square. So we can write it like 1 minus cos theta 1 plus cos theta, that is a minus b into a plus b, right? This will be cancelled. So we are left with 1 plus cos theta by cos theta. Just break the LCM. It's 1 upon cos theta plus cos theta by cos theta. So it's sec theta plus 1 or 1 plus sec theta, right? Quite simple. Okay, we just keep on putting the value, keep on solving, we'll be getting the right hand side. So that's 1 plus sec theta that we had to prove, right? So we started with this side, that is left hand side, and we reached finally to the right hand side. Okay, I hope you are clear. Now friends, we have this question. Further, we take left hand side. So we have to prove this to be 1, right? So this is a plus b and this is a minus b. So a plus b into a minus b is a square minus b square, right? So 1 minus cos square theta, right? And cot square theta can be written as, see, tan theta is what? Sin theta by cos theta. So cot theta will be what? Cos theta by sin theta, because tan theta into cot theta is 1, or they are reciprocal of each other, right? So instead of cot square theta, what I can do? Cos square theta by sin square theta, right? Now 1 minus cos square theta is what? It's sin square theta, because sin square theta plus cos square theta is 1. You need to remember all the identities which we derived. So 1 minus cos square theta is sin square theta, right? Into, if we take LCM, it will be sin square theta plus cos square theta. And this is by sin square theta, right? Now this sin square theta and this sin square theta, they will get cancelled, and sin square theta plus cos square theta is equal to 1, that we have already derived in our first lecture, right? So precisely it is 1 that we had to prove, right? So simply you can solve it, just put the relationship and just solve it. Okay, now friends, we have this question. Further, we have to prove the left hand side equal to 1. So we start with left hand side. It's 1 upon 1 plus 10 square a plus 1 upon 1 plus cot square a. Now we know the relationship, that is 1 plus 10 square a is equal to sec square a, and 1 plus cot square a is equal to cosec square a, right? So I put the value of 1 plus 10 square a as sec square a and 1 plus cot square a as cosec square a, right? So it's 1 upon sec square a plus this is 1 upon cosec square a. Now 1 upon sec square a will be what? Cos square a, because sec and cos, they are reciprocal of each other. So 1 upon sec square a will be cos square a, and 1 upon cosec square a will be sin square a, because sin a and cosec a, these two are also reciprocal of each other. Now we know the relationship, cos square a plus sin square a is what? It's 1. So that's RHS, that's right hand side, right? Just simply we put the identity, put the value of 1 plus 10 square a and 1 plus cot square a, and we got the answer. Okay. Now we have this. Further, we start with left hand side. We take LCM. So this is a plus b into a minus b format. So that's 1 plus sin a into 1 minus sin a. So that will be 1 minus sin square a, right? Or if you don't want to write this on the first time, just write it like this only. Now if we take LCM, 1 plus sin a will be cancelled from 1 plus sin a. So here we will write 1 minus sin a. Similarly, 1 minus sin a will be cancelled from this. So here we'll be writing 1 plus sin a. Right? So this is cancelled. So this is 2 upon 1 plus sin a into 1 minus sin a. So 1 plus sin a into 1 minus sin a, that is a plus b into a minus b format. So that is equal to a square minus b square. So it's 1 minus sin square a. So 2 upon 1 minus sin square is what? Cos square a. So it's 2 into 1 upon cos square a. Now cos square a is reciprocal of sec square a. So 1 upon cos square a can be written as sec square a. So that's 2 sec square a that we want for the right hand side, right? Okay. I hope you must be gaining some confidence in trigonometric identities. You just solve it on your own, right? Just see the solution, try it on your own. So gradually you'll be comfortable. Now let's do this question. We start with further LHS, that's left hand side. One plus sin a by cos a plus cos a upon 1 plus sin a, right? First of all, let's take LCM. So it's 1 plus sin a into cos a. Now cos a cancelled. 1 plus sin a will be multiplied by 1 plus sin a. So that's 1 plus sin a whole square plus 1 plus sin a cancelled. Cos a into cos a, that's cos square a, right? Now we just open the bracket, a plus b whole square. So it's 1 plus 2 sin a plus sin square a plus cos square a upon 1 plus sin a into cos a. Now sin square a plus cos square a is 1, right? So this is 1 and this is 1, that is 2 plus 2 sin a upon 1 plus sin a cos a, right? Now I can take 2 as common. So it's 1 plus sin a upon 1 plus sin a into cos a. Now this and this is cancelled. So now we are having 2 into 1 upon cos a. So 1 upon cos a is nothing but sec a. So it's 2 sec a. That's RHS that we had to prove, right? It's there. Okay. So we started with left hand side and we reached right hand side. I hope you are clear. Now let's see this question. It's 1 plus 10a whole square plus 1 minus 10a whole square is equal to 2 sec square a. So further we begin with left hand side. Now a plus b whole square is what? We have already discussed the algebraic identities in the previous session. Right? So 1 plus 10a, that is a plus b whole square, that will be 1 plus 2 10a plus 10 square a, and if it is minus over here it will be negative, right? So a minus b whole square will be 1 minus 2ab plus b square, right? So this and this is cancelled. So now we are getting 1 plus 10 square a plus 1 plus 10 square a. Now 1 plus 10 square a is what? It's sec square a. This is the identity that we have already proved in the first session. So 1 plus 10 square a is sec square a, and further 1 plus 10 square a is sec square a. So it's 2 times sec square a, that's RHS. Right? So we started with this and we reached this. Okay? I hope you are getting me. Now let's try this question. That sec square a plus cosec square a is equal to tan a plus cot a. So let's start with left hand side. Sec square a can be written as 1 upon cos square a, and cosec square a can be written as 1 upon sin square a, right? Now let's take LCM. So that's sin square a plus cos square a upon cos square a sin square a, right? So that's sin square a plus cos square a is 1, that we have already proved in the previous session. 1 upon this is cos square a sin square a, so if after coming from the square root it will be sin a cos a, right? But we want the right hand side to be in tan a and cot a, right? So what we can do, further I put the value of 1 as sin square a plus cos square a, right? So it's sin square a plus cos square a upon sin a cos a, right? If sin square a plus cos square a can be written as 1, that means 1 can be written as sin square a plus cos square a. Now I just break the LCM. So it's sin square a upon sin a cos a plus cos square a upon sin a cos a, right? So it's this and this is this. So it's sin a by cos a, that is tan a, and this is cos a by sin a, that is cot a, and that is right hand side. Okay, I hope you are getting me. It's pretty simple, just a bit twist is there. Instead of 1 you have to put this value, right? So you can break the LCM and you can arrive at right hand side. Okay, now we have this question. Tan square a plus cot square a plus 2 is sec square a cosec square a. Further we start with left hand side. So it's tan square a plus cot square a plus 2, right? Now we know that 1 plus tan square a is sec square a and 1 plus cot square a is cosec square a, right? So what I do, I just break this 2 and take 1 over here and 1 over here, right? So 1 plus tan square a and 1 plus cot square a. So 1 plus tan square a is sec square a and 1 plus cot square a is cosec square a, right? So sec square a can be written as 1 upon cos square a and cosec square a can be written as 1 upon sin square a. Now I can take LCM. So that is cos square a into sin square a. Now that will be sin square a plus cos square a. So that's 1 upon cos square a into 1 upon sin square a, that is sec square a into cosec square A, right? 1 upon cos square A is sec square A and 1 upon sin square A is cosec square A, right? So that was right hand side. Okay, so just simply I put the formula of 1 plus tan square A, that is sec square A, that is identity we can say, and just solve it. You'll be getting the right hand side very easily. Okay. Friends, alternatively, what we can do is, we convert tan and cot to sin and cos. Now tan square A will be what? Sin square A by cos square A, and it will be cos square A by sin square A, and that is plus 2. I am starting with left hand side only. Now I take LCM, that is cos square A sin square A, right? Now cos square A will be cancelled. So this is sin square A into sin square, that is sin 4A. Similarly sin square A will be cancelled. So it will be cos 4A plus 2 sin square A cos square A. Now this is what? Sin square A whole square plus cos square A whole square plus 2 sin A whole square and cos A whole square, right? Divided by cos square A sin square A. Now what? This is, if sin square A is A, or we can say x, so it's x square plus y square plus 2xy, right? So that is what? X plus y whole square. If I assume sin A to be x and cos A to be y, so it will be x square plus y square plus 2xy, right? This. Okay, so that's what? X plus y whole square. I just write the whole thing in bracket. Okay, so precisely what is happening? It is sine, I just write x plus y, the value of x and y, that is sine square A plus cos square A whole square. That is in numerator, and in denominator same. Now we know sine square A plus cos square is what? 1. So 1 square will be 1 only. So it's 1 upon cos square A into 1 upon sine square A. So 1 upon cos square A will be sec square A into 1 upon sine square A is equal to cosec square A. So that's RHS, right? So either way we can go. This is the algebraic identity that we should be knowing, that x4 plus y4 plus 2x square y square is actually x square plus y square whole square, right? This is the algebraic identity, and I am sure you are clear now. Now we have this question: sin A 1 plus tan A plus cos A 1 plus cot A sec A plus cosec A we have to prove. Further we'll start from the left hand side. So it's sin A 1 plus, instead of tan A I'll be putting sin A by cos A, right? Then plus cos A, it's 1 plus cos A by sin A, right? Cot A will be cos A by sin A. Now just open the bracket. It's sin A only plus sin square A by cos A plus cos A plus cos square A by sin A. Now friends, let's take LCM. So in the denominator we have sin A cos A, right? So here we have 1, here we have 1. So it's 1 into this. So sin A cos A into sin A will be sin square A cos A plus cos A will be cancelled. So it will be sin cube A plus this is sin A cos square A plus sin A is cancelled. So it is cos cube A, right? Now this is sin cube A plus cos cube A plus sin A cos A. From these two I can take sin A and cos A common, so I'll be left with sin A plus cos A, right? By sin A cos A. Okay, now what is the formula for A cube plus B cube? I just write it over here. A cube plus B cube is A plus B, A square minus AB plus B square, right? So I just put the value of sin cube plus cos cube A, so that is sin A plus cos A by sin square A minus sin A cos A plus cos square A plus this remaining thing, that is sin A cos A into sin A plus cos A, right? Right now I'm not writing down the denominator because as of now we are not doing the calculation and some space problem is there. So I'm just writing down the numerator, right? Now just look at numerator very carefully. It's sin A plus cos A over here and sin A plus cos A over here. So we can take it as common. So it's sin A plus cos A. Now from this we have already taken as common. Now sin square A plus cos square A is 1 and that is minus sin A cos A, and this is plus sin A cos A, right? So this will be cancelled. So finally we are left with sin A plus cos A, and in the denominator we have sin A cos A, right? Now we can break the LCM. So divide sin A by sin A cos A plus cos A by sin A cos A. So it's 1 upon cos A and it is 1 upon sin A. Now what is 1 upon cos A? That is sec A, and what is 1 upon sin A? That is cosec A. So that is what RHS that we had to prove, right? This is there. Okay, the problem is a bit lengthy, but believe me, it's not complicated. It's very simple. You just have to apply algebraic identities, take out the common data and cancel the data which is getting cancelled, and you'll be getting the right hand side, right? No need to worry much. Just practice the sum for 2-3 times. You'll be getting it. Okay. Our friends will be taking more algebraic identities, more problems on trigonometry in our next session. Do revise this session and the previous one so you will feel comfortable in the next session, because the level of the problems will be taking in the next session will be a bit higher, right? So you should be conceptually clear. You must be knowing all the algebraic identities and trigonometric identities as well, right? So see you in the next session. Bye-bye.